Okay, question 7. Um, I've got a Bermuda Triangle. I've been told the vertices, the angles are at B, M, and P for Bermuda, Miami, and Puerto Rico, respectively. I've been asked to find the size, to calculate the size of the angle BM, BPM, sorry. Remember, when naming angles like this, I'm going from B down to P along to M. So I've drawn out that angle there. That is what I've been asked to calculate the size of. So that's the size of the angle I'm trying to calculate. Um, no right angles there, so I can't be using right angled trig, but studying the formula list at the front of your paper, you'll see you've got 3 trig rules. You've got the sine rule, the cosine rule, one for the area of the triangle. Only one of these is used for finding an angle when we know all 3 sides, and that would be the cosine rule in this format. So cosine A equals b squared plus c squared minus a squared all over 2bc. Unfortunately, we don't have A, B, C. We've got B, P, and M, but we can rewrite this. We're trying to find the angle labelled P, and we need to remember the first 2 sides here are the ones enclosing my angle. So labelling this, opposite M is M, opposite B is little b, opposite P, little p there. So my 2 enclosing sides, b squared plus m squared minus, now a is opposite a, big A is opposite little a, so similarly opposite big P to little p, all over 2bc, the 2 enclosing sides, 2bm. I need to substitute my values in. 650 squared plus 1000 squared minus 1100 squared all over 2 lots of 650 times 1000. Now you can type that all into your calculator, and that would give you 0.163, so on. We don't want cosine P, we want the angle P on its own. So I take the inverse cosine of that. Now, remember there's no need for you to actually type that in. You can use the answer button in your calculator. So the inverse cosine of that, 80.592. Nothing mentioned in the question about rounding, so I'm just going to round that to 1 decimal place. Right, question 8, a percentage question. I've got the value of a boat has decreased from 35,000 to 32,200 in 1 year. What is the percentage decrease? First things first, I would figure out the actual decrease. So the decrease, just see how much the price has fallen by. that would give me £2,800. I need to write that as a percentage decrease. So I would take how much it's changed by and divide that by the original amount, £35,000. Now, typing that into my calculator would give me that as a decimal. So to convert to decimal to a percentage, I would need to multiply that by 100. So typing that into our calculator gives us a nice answer of 8%. Quick way to check is I would be finding 8% of the original amount and subtracting it. So I would be quickly typing into my calculator just as a check. Well, taking away 8% would be finding 92%. 0.92 times 35,000 does indeed give me that. So I know I've got that question correct. Part B leads directly on from that. If the value of the boat continues to fall, what would its value be after a further 3 years? So an extra 3 years after that. So an 8% decrease means I would need to find 92% of its value. So this is essentially a compound interest question. The same process. It costs 32,200. I'm going to find 92% of that. So I've converted that to a decimal. And I'm going to do that for a further 3 years. So typing that carefully into my calculator gives the number 25,073.75. Got my pound symbol, 2 decimal places because it's money. But going back to read the question, I'm getting a mark for my rounding here because it actually states to the nearest £100. So to the nearest £100, well, I've got 25,000, 0 hundreds, but the 70 would force me to round up. So 25,100 pounds to the nearest £100. Question 9. Looking at this straight away, this should scream simultaneous equations. 2 different arrangements, 2 different lengths, 6 marks. So the way this would be marked, I would guess, is, well, 1 mark for forming an equation, 2 beads plus 5 pearls, just reading it from there, comes to 5.2 centimeters. Another mark for forming the next equation, 3b plus 2 pearls, 5.6 centimeters. Decimals inside our equation. That's okay, we're using a calculator. And so long as we're careful, our answers shouldn't have any reoccurring decimals in them. We should hopefully have something with just 1 decimal place at the end. Okay, so I've got 2 equations. I'm going to label them 1 and 2. And then I need to decide which variable I'm going to eliminate. I'm going to eliminate p. So I'm going to take 1 and I'm going to double it, which will give me 10p there. I'll multiply this by 5 to give me 10p there as well. So, doubling my first equation. 4b plus 10p equals 10.4. And I'm going to call this new equation equation 3. Take my second equation, multiply it by 5, 15b plus 10p equals 5.6 times 5. So remember to multiply both sides of your equation, and I'd call that 4. That would be us earned our third mark there as well. As we've demonstrated, we know we need to change at least one of our equations. I am now going to do 4, and I'm going to subtract 3. I could do 3 subtract 4, but looking at these numbers here, these are the bigger ones. I want to avoid working with negative numbers wherever possible. So 8 minus 4 would give me 11b. 10 and 10, 10 subtract 10, that'll give me nothing. 28 minus 10.4 would give me 17.6. So to get b on its own, I'm going to divide by 11, which gives me 1.6. So I've got a decimal answer, but like I said before, it's not a reoccurring decimal, so it's not that bad to deal with. I need to take my value of 1.6 and substitute it into any of my original equations. So I could substitute that into 1, 2, 3 or 4 if I wanted. I'm going to substitute it into 2 just because the number of p's there is smaller. And I've just spotted that should be 3b there. So I have 3 lots of 1.6 plus 2p is equal 5.6. Let's see, so that would give me 4.8 plus 2p equals 5.6. Subtracting 4.8 from each side would give me 0.8. So dividing by 2 gives me that. Find the length of one bead and one pearl. Always useful in these questions, always a good idea to put them back into context. So a pearl is 0.4 centimeters long, and B stands for bead, so a bead is 1.6 centimeters long. Good idea, I suppose, would be to look back to the original diagram. My beads, are they bigger than my pearls? 2 beads and 5 pearls. Yep, so the pearls are definitely the smaller in that diagram there. Okay, similarity question. Not a similarity question. Well, I suppose similarity question and a scale factor question. We've been told that the beads are mathematically similar. I've been told the height of the smaller one is 0.8, and I also know its area is 0.6 centimeters squared. I'm told the height of the larger bead is 4 centimeters. Find the area of the larger bead. So, a couple things I need to do here. First things first, I would need to find my scale factor. Now, my scale factor, well, I can construct my fraction 4 over 0.8, as I've got the size of the bigger one divided by the size of the smaller one. Putting that into my calculator gives me 5. If we think about it going this way, it makes sense I'm timesing by 5 as the object's getting larger, the whole stone is getting bigger. If it was going in reverse, if I was going from this one back to this one, I'd be expecting a scale factor less than 1, but I'm enlarging, so I've got a scale factor more than 1. I want to find the area scale factor. Area scale factor, well, I take my length scale factor, and area is a two-dimensional quantity, so I square it. So my area square factor is 25. If my scale factor was a horrible fraction, I would probably be leaving it just written as that, to type it into my calculator. So the area is going to be 0.6 centimeters, the area of the smaller one, and I'm going to multiply it by my area scale factor, which gives me an area of 15 centimeters squared. Well, let's read the question. We've got 25 seconds to answer a question in a quiz. And it's showing us how far round the clock that goes. Time's indicated on a clock. The tip of the clock hand moves through the arc AB as shown. So it's moving in the direction I've indicated there. Calculate the size of the angle AOB. And it's worth 1 mark there. Well, it's went through, I suppose there's a couple of ways you can do this. It went through 25 out of 60, since there's 60 minutes, 60 seconds in a minute, and simplifying that fraction either mentally or using your calculator, since it's a calculator question, gives me 5 over 12. I suppose another way to think about it is I've got 1, 2, 3, 4, 5 divisions there, and the clock would be split up out of into 12 divisions. So the size of the angle, it's going to be 5/12ths of 360, which you can type into your calculator as 5/12ths times 360. That'd give 150 degrees. Makes sense, it's a bit less than a half turn. The length of the arc AB, so this bit here, is 120 centimeters. Calculate the length of the clock hand. Now, to highlight the clock hand, I've got here. The clock hand goes from the center of the circle out to the edge. So what it's asking us is it's essentially saying the length of the clock hand, that's the radius. Now I've got the arc length. So a good place to start with this would be to actually write down the formula for calculating the arc length. Your arc is equal to however big your angle is over 360 times, now the arc, that's the part of the circumference, so it's going to be times pi d, the circumference of the whole circle. And what we could do is we could put in all the numbers we know. We've been told the arc length is 120 centimeters. We know that angle is 150 over 360. I suppose here I could be using that fraction we figured out before. It really is down to you. It wouldn't be any more wrong, or wouldn't be any more correct. Times pi. Now we don't know the diameter, but that's okay, because we're trying to find the radius. So if we get the diameter, well, that's essentially the problem solved for us. I want to get rid of all of this here to get D on its own. Everything there I've highlighted in the box, that's being multiplied by D. So I suppose the easiest and quickest way to get D on its own is to take 120 and divide it by that. That would leave me with D there on its own. Typing it into the calculator, note the brackets. I'm dividing 120 by all of that. So typing that in the brackets, gives me 91.67, etc. So on. And that would be in centimetres. So the diameter of the clock is a little bit over 91 centimetres. The radius is going to be half of that. So dividing by 2, 45.83, so on. So I could round that to, now it doesn't say anything about rounding, so 1 decimal place. The radius of the clock, and thus the length of the clock hand would be 45.8 centimetres.